Okay, so for 8th grade Apex math, the converse to the Pythagorean theorem. So the Pythagorean theorem says if you have a right triangle, then you get that formula of a squared plus b squared equals c squared, or how I like to say it, leg squared plus leg squared equals hypotenuse squared. Okay. The converse of a theorem goes backwards, okay? Or you reverse your two statements. So for example, if I said, if, and I'll just write it up here. So if I said something like, so if I say, hold on a second, everything's moving. If I said something like, let's type, it's faster. If it rains, then I'll bring an umbrella, something like that, right? So here's my statement. My converse would switch my two my two statements within there, right? So it would say if I bring an umbrella, then it will rain. I don't know, something like that. Now, just because it's a converse doesn't mean it's true, and just because it's a statement doesn't mean it's true. It's just a statement. So here, this says the converse of the Pythagorean theorem. Okay, so complete each sentence to review the Pythagorean theorem. The Pythagorean theorem states that any right triangle, the sum of the squares of the two shorter sides. Let me, this is moving everywhere. Of the two shorter sides equals the square of the longest side, right? The Pythagorean theorem is written as, now I write it as this, okay? So I write leg squared plus leg squared equals hypotenuse squared. I don't write it like a squared plus b squared equals c squared. And the reason why I don't is because everyone always thinks that the missing side is c, and that's not true all the time. It's only true if the hypotenuse is missing. Does that make sense? So sometimes I don't give you the leg and you'll still put it in hypotenuse, and that's not correct. So in your own words, what is the converse of a logical statement? So a converse just switches. It just switches your statement, okay? I say converse, I just use the word switch. So hopefully you understand what I mean by switch. If you think about this part here, the umbrella part is not in the second part anymore. It's not the then part, it's the if part. And the rain part is now in the then part. So they switch spots. Circle the correct words to describe the truth value of a converse of a logical statement. So if a given logical statement is true, the converse is definitely true. Well, that's not true here. If I bring an umbrella, do I have control over the rain? Of course not. So the answer is not definitely. Let's see, it's not definitely true. It could be true, but it's not definitely false. So the answer is it's not always true. It could be true, but it doesn't have to be true. So fill in the table with the converse of each logical statement, then decide whether each converse is always true. If today is Friday, then tomorrow is Saturday. Is that true? And you're like, yeah. The converse, I'm just going to shorten it up so that I can, we can move on. It's if tomorrow is Saturday, then today is Friday. Is that true? If tomorrow is Saturday, then today is Friday. Yeah, this is true. Right? So then it says, if it is raining, then there are clouds in the sky. If it is raining, then there are clouds in the sky. So this one would be if clouds, then rain. Again, I'm making these really short so I don't have to type everything. So is that true? If there's clouds in the sky, is it raining? And you're like, no, that's not true. So as you can see, sometimes it is true and sometimes it is not. So the Pythagorean theorem is a logical statement that is true. Complete the diagram by writing out the converse of the Pythagorean theorem. Assume the triangles have side lengths A, B, and C, where C is the longest. Again, I'm going to cross this out And I'm just going to put longest. I like longest. I don't necessarily like hypotenuse in this sense. I'll explain why. Okay, so I'm going to type this one out because it'll take me a long time to actually write it. I'm a faster typer than writer. So it should say if a squared plus b squared equals to the longest squared, right? If that's true, then the triangle is a right triangle, right? So I'm going to put this right here. Okay, so if it's true that a squared plus b squared equals the longest side squared, then the triangle is a right triangle. Now, the reason why, if some of you are saying, hey, Ms. Johnson, how come you didn't just use leg squared plus leg squared equals hypotenuse squared? The reason why I didn't is technically a hypotenuse is only exists in a right triangle. So if I have the word hypotenuse, then automatically, duh, it's a right triangle. So I can't necessarily use the word hypotenuse here because we don't actually know if it is a right triangle, okay? So this one says, watch the animation about the Pythagorean theorem converse. That's you guys doing that on your own. Then circle the words that describe whether each example supports the converse. So does 6 squared plus 8 squared equals 10 squared? Yes or no? So then all you're doing is you're checking that on a calculator. So I'm going to use my friend Desmos because Desmos is a way better calculator than the one on my computer. So I'm going to show you just off to the side right here. So it says 6 squared plus 8 squared, and that's 100. And then in case you don't know, 10 squared is 100. So is that true? And you're like, yes, that's true. Right? Can these segments form a right triangle? And you say yes, right? Because these three sides, it holds true that a squared plus b squared equals the longest side squared. A squared plus b squared equals the longest side. 10 is the longest side, right? Then we make a right, it does make a right triangle, right? So the converse of the Pythagorean theorem is true. Okay, so does 5 squared plus 12 squared equals 13 squared? I don't know. Let's try. I actually do know. Sorry. Does 5 squared plus 12 squared? And again, reminding, oops, not 12 squared. Reminding you a couple of things. Make sure that the one that's by himself is the longest side, which makes sense, right? It should make sense that he gets to be by himself because he's the biggest side. And then, so if you don't know, 169 is the square of 13. So the answer is yes. Does it form a right triangle? Yes. Is it true? Yes. Last but not least, 4 squared plus 6 squared equals 7 squared. So let's see. So 4 squared plus 6 squared. So I don't know if you know, but 7 squared is not 52. So the answer is no. Right? No. Can these segments form a right triangle? The answer is no, because you didn't give me a squared plus b squared equals the longest side squared. So no. Is the converse of the Pythagorean theorem, so the converse of the Pythagorean theorem, it's still true because it says if this is true, then it's a right triangle. So you can also understand that if it does not equal, then it's not a right triangle. So this is still true. Does that make sense? I'm still saying that the Pythagorean, the converse is still true, because if this does not work, then this does not work. So a logical statement goes like this. So let's go back to this one. If today is not Friday, then tomorrow is not Saturday. That makes sense, right? Right, that makes sense. Or if tomorrow is not Saturday, then today can't be Friday, right? Right, like right now, today is Tuesday. So if tomorrow is not Saturday, which that's true, then today is not Friday. That is also true. So that statement still holds. Okay, moving on. Use the Pythagorean theorem converse to determine whether a triangle with side lengths of 4, 5, and 7 is a right triangle. So I want you to pause right now, pause the video, and see if this actually works. Does 4 squared plus 5 squared equal 7 squared? Go ahead and do that. We'll come back and check right now. Okay, hopefully you paused it and you actually did this work on your own. Otherwise, you are not going to get better at doing this converse to the Pythagorean theorem. You're not going to understand what it's doing. So 4 squared plus 5 squared, right? Does that equal to 7 squared? Well, 41 does not equal to 7 squared. I already know that. So no. So they wanted you to show your work. So let's do that. So 4 squared is 16 plus 25 is 41. 41 does not equal to 49. So the answer is no, right? Based on your answer in part A, can these segments form a right triangle? Well, let's see. According to the converse says, if this is true, then it's a right triangle. It wasn't true. So is it a right triangle? You should say no. When is the Pythagorean converse useful in real life? Give at least 2 specific examples. Actually, this is pretty interesting. I was watching a video about a guy building, and one of the ways that he made sure, and it's called squaring, that it was a square. And really what he means is it was a right angle, was that he measured his sides of the building and he measured the diagonal. So could you imagine this building? He measured this wall, he measured this wall. Sorry, my walls are crooked. Thank goodness I'm not a builder, right? So he measured this wall, he measured this wall, and then he measured the diagonal to see if this was a right angle, right? So I don't know, maybe this was, I don't know, 5 feet, this was 12 feet, and this was 13 feet. And he like measured really well, because again, if you don't measure really well, then we don't know that this is square. So he measured really well, and he basically used the Pythagorean theorem to teach that. So there's other examples that you all can come up with. Right now, this is actually one that I saw in the real world, which I thought was really neat. He actually used the Pythagorean theorem to make sure that this was square, right? That's what they call it in the building world, that this is square. So complete the sentence to describe Pythagorean triples. So what a Pythagorean triple is 3 numbers, like for example, 6, 8, and 10, or 5, 12, and 13, are the side lengths of a right triangle. So a Pythagorean triple is a set of 3 integers that satisfies the converse to the Pythagorean theorem. Okay, so 4 different sets of numbers are used in the study guide. Find the 2 sets of that are Pythagorean triples, and then write them in the left box. Then write the other 2 sets on the left box. So they wanted you to go up here and look for sets that worked. Obviously, it's going to be these 2, 6, 8, 10, 5, 12, 13. And these other ones, 4, 6, 7, and 4, 5, 7, both don't work. So I think it was 6, 8, and 10, 5, 12, and 13. And I think it was 4, 6, 7, and 4, 5, 7. So basically, I don't know why it is slightly off, but it is for some reason. So I apologize. These numbers, without me even checking, I already know that they're a triple. Which Pythagorean triple in question 10 is a multiple of another triple? So if I look at these, which one is a multiple of another triple? Well, these 3 don't multiply, don't have a common factor, but these 3 do. So 6, 8, and 10. If you look at 6, 8, and 10, you divide each of them by 2, you get 3, 4, and 5, which is the most famous triple. I don't know why it's all off. My iPad and my other thing are not syncing. So with that being said, the biggest thing that you should have learned in this whole section is how to tell if 3 numbers give you a right triangle and you are using the converse to that Pythagorean theorem. So that's how you know, right? If this sentence is true for some 3 lengths of a triangle, then you now know that it is a right triangle.